Hey everyone, so we just finished up with section 6.1 and now we're going to move on to 6.2, which is about applications of the normal distribution. So now that we've mastered finding probabilities of standard normally distributed variables in section 6.1, let's apply the same methods to finding probabilities of just normally distributed variables. Now, here is the mathematical equation for the normal distribution. So we have 1 divided by the square root of 2 pi sigma squared times e to the minus 1 over 2 times x minus mu over sigma, and this quantity squared. Now this formula doesn't look quite fun to use, so for each time we want to know the corresponding probability of something being less than or equal to some data value, we need to plug it into this formula here, and that's not going to be fun. This is why we use these z-scores. We can take these normally distributed variables, turn them into standardly normally distributed random variables, and then we can use those z-scores in the standard normal tables to find the associated probabilities. So we're going to start with some variable x that is distributed normally with some mean of mu and some standard deviation of sigma. Then using the z-score formula, we convert this to z distribution, which is a standard normal that has a mean of 0 and a standard deviation of 1. So we're doing this to make it easier for ourselves to find the probabilities associated with these particular values we're interested in. Now let's go through the first part. So if we are given a mean and standard deviation of a normally distributed random variable, so the mean, that means we know mu, and the standard deviation, we know sigma, then we can use the z-score formula to transform the data into standard normal distribution via the z-score formula. Then we can use the methods from section 6.1 to calculate the probabilities that we want. Then let's use these following steps to do so. So step 1, draw the normal curve and shade the appropriate region. So it's the same step as we had before. Then the second step, transform the data value x you're interested in to a z-score. And how do we do that? By just using the formula we introduced in section 6.1. Z is equal to the data value of interest x minus the mean mu and divided by its corresponding standard deviation sigma. Now a third step, which is optional, this is just what we did in the last section. We draw the corresponding z-curve and again to shade the appropriate region. So this step is nothing new. So I'm going to go back to this step, and I'm actually going to graphically draw what I mean by draw the normal curve and shade the appropriate region. Then we have our random variable x, and it has a normal distribution, so we'll say it looks like this. And it has a mean at the center, mu, and the spread is measured by sigma. And the fourth step, once we have the z-score we're interested in, and we actually know the region we're looking at, we can then use the table as before to find the associated probabilities. Then using these 4 steps, we want to go over a couple of examples that help to illustrate this idea. This first one says an adult has on average 5.2 liters of blood. Assume the variable is normally distributed with a standard deviation of 0.3 liters. Find the percentage of people who have less than 5.4 liters of blood in their system. The first thing we want to do is first identify what is the random variable we're looking at here. In this problem, we're mentioning liters of blood. So that means that X is going to be the amount of blood and that's in liters. And what is the distribution of this? So X is said to be approximately normally distributed with a mean of 5.2. So that means it's normally distributed with mu equals 5.2 and a standard deviation of 0.3. So sigma is equal to 0.3. So now we've identified the mean, the standard deviation, and the distribution of X. Now let's go to the first step. Let's draw the normal curve and shade the appropriate region. So draw the normal curve. So our normal curve looks like this. We have the x-axis, which is the possible outcomes we could have for the amount of blood, and then we're going to draw the normal curve on that. That was not very good, but it's okay. And here in the center, we have the mean, which is 5.2. Now it says find the percentage of people who have less than 5.4 liters of blood in their system. So we're interested in the area to the left of 5.4. So say here is 5.4. We're interested in the area to the left of that. So this area over here. And that's the first step. We drew the normal curve and we shaded the region we're looking at. The next step is going to be to convert this data value we have into a z-score. So the second step, transform 5.4 to a z-score. And we know that z is equal to the data value we're interested in minus the mean over the standard deviation. In this case, the data value we're looking at is 5.4. The mean is given 5.2. And we're given the standard deviation as well is 0.3. Then I can compute the z-score. We want to round these to 2 decimal places so we can find the corresponding area in the table. So the z-score to 2 decimal places is 0.67. Now the third step was draw the z-curve and shade the appropriate region. So I'm just going to say draw curve, and we're going to draw the z-curve and shade the appropriate region. So here we have the distribution of our z-scores, and we're still looking at the area to the left, but in this case, we're looking at the area to the left of our z-score. So we have 0.67 is right here, and we're interested in the area to the left of that. Then, since we're interested in the area to the left, we don't need to do anything special. We just need to find this probability in the table. Then, this step 4, I'm just going to write the step and then I will actually do it. Find the probability in the table. And so this says the probability of x being less than 5.4 is the same as the probability of z being less than 0.67. And then if I look this up in the standard normal distribution table, let's do that real quick. So 0.67, that is 0.7486. So that area is 0.746. And that is how you will solve just one of these problems. We want to start out by identifying the distribution of our random variable. So we need to find the mean and the standard deviation. Then we want to identify what one we're interested in. So in this case, we were interested in who have less than 5.4 liters of blood. So 5.4 was the stated value we were interested in, x. And then we find its corresponding z-score. And then using the z-score, we can find the associated probability by using our table, just like we did in section 6.1. Now let's move on to the second example. This second example says, each month, an American household generates on average 28 pounds of newspaper for garbage or recycling. Assume the variable is approximately normally distributed and the standard deviation is 2 pounds. If a household is selected at random, find the probability of the following. Now in this case, what is the random variable we're looking at? So in this case, we're looking at pounds of newspaper. So our random variable x will be pounds of newspaper. And what is the distribution of x? So x is distributed. It says approximately normal. So normal. And what is the mean? It says on average a household generates 28 pounds. So mu is 28. And it says the standard deviation is 2 pounds. So sigma is 2. Then let's look at these two questions. It says, find the probability of it generating between 27 and 31 pounds. So the first step, we can draw the normal curve. And shade the appropriate region. So if we do that, here is our distribution of pounds of newspaper. At the mean, we have the middle. At the middle, we have the mean of 28. And we're interested in getting between 27 and 31 pounds of newspaper. That's the probability we want. Now to do that, we're going to have to convert both of these data values of interest into z-scores first. So then the second step, transform 27 and 31 into z-scores. Using that same formula before. So for 27, its z-score is z is equal to, so the data value of interest is 27 minus the mean, which was 28, and then divide by the standard deviation, which was 2. And this will get us negative 1/2 or negative 0.5. Now for the next one, the z-score for 31. So our data value of interest is to 31. So that would be 31 minus the mean 28 divided by the standard deviation of 2. And if I simplify that to 2 decimal places, that is 1.50. Now, using this same idea, if we draw the z-curve and shade the appropriate region, if we do that, let's say the z-curve is over here. Then we're interested in the probability of z being in between negative 0.5 to 1.5. And that is the area we want in the middle of those. Then it's just a simple problem just like we did in section 6.1. Then part 4, find the probability. So to find the probability we want, we need to look at the probability of z being less than 1.50, and then subtract off the probability of z being less than or equal to negative 0.5. It's that same idea. To find the area in between two z-scores, we want to take the probability of it being less than or equal to the higher z-score minus the probability of it being less than or equal to the lower z-score. Then, looking up these two in the table, the probability of z being less than or equal to 1.50, 0.9332. And the probability of z being less than or equal to negative 0.5 is 0.308. And then if you simplify that, you will get 0.6247. So that is the area of getting between 27 and 31 pounds per month. Now, one step I didn't mention in here is the probability we're actually looking at is the probability of z being in between negative 0.5 to 1.5. And then that becomes this area here, just the difference between the higher minus the lower z-score. So I just didn't put that step in here, but I will do that here just to reemphasize what we were actually looking at. And this is negative 0.5. Then our probability of interest was this one right here. Now, this next one, find the probability of it generating more than 30.2 pounds per month. So first step, let's again draw the normal curve. And shade the appropriate region. If I do that, here I have the distribution of the pounds of newspaper. The mean in the middle here is 28, and I want the area to the right of 30.2 pounds per month. So I want this area right here. Now, I want to take this 30.2 and convert it to a z-score. So convert 30.2 to z-score. So earlier I said transform. It doesn't matter. It means the same thing. Then the z-score corresponding to 30.2 can be found by 30.2 minus the mean of 28, and then divide by the standard deviation of 2. And that will give me a z-score of 1.10. Now, if you want to draw out the graph again for the third step, draw the z-curve and shade the appropriate region. So draw the z-curve. If I do that, here's the distribution of the z-scores. So I got a z-score of 1.10, and again, I am interested in the area to the right of that. So if I go here, 1.10, I want to look at the area to the right of that z-score. And using that same idea as we did in section 6.1, if I want to find the area to the right, I just take 1 minus the area to the left. So then the probability we're looking at, probability is the probability of z being greater than 1.10 is equal to 1 minus the probability of z being less than or equal to 1.10. And then if I look up this probability in the table, I will get 0.8643. And that will give me the probability I'm interested in is 0.1357. And that's the area over here in green. So if it would have said less than 30.2, I would have just taken this area here to the left of 1.10, that z-score. But since in this case it said more, I need to take the area to the right. So I need to find the area to the left, and then take 1 minus it to find the area to the right. Now, those two examples are when we actually knew the mean and the standard deviation. Now, what happens if we are given the mean, standard deviation, and the probability and asked to calculate some particular x value? So we're looking for that particular data value with that mean, that standard deviation, and that probability. So the first step is to draw the normal curve. And shade the appropriate region. The second step, find the area to the left of the unknown x value. And this x here is the data value we're interested in. Then use the table, so the standard normal table, to find the corresponding z-score. So first I need to find the area to the left because that's what the actual table would give me, and then I need to go look in that table to find the z-score given that probability. And then the third step, I need to convert the z-score to an x value. And I do that by x, the data value I'm interested in, is equal to the z-score corresponding times sigma plus mu. And why is that? So let's look at the formula for a z-score. So z is equal to the unknown data value minus the mean divided by its corresponding standard deviation. So I know the z-score because I know the probability to the left. Then I can find the z-score. I know the mean and I know the standard deviation. And all I want to do is figure out what is x. So I need to isolate x. So to do that, I first multiply by sigma on both sides. So that tells me that z sigma is equal to x minus mu. And then to isolate x, I just add mu over, and I get x equals z sigma plus mu, just like that formula there. Now let's look at an example to illustrate this. It says, to qualify for an academy, students must score in the top 10% on an entrance exam. Assume test scores are normally distributed, and the exam has a mean of 200 with a standard deviation of 20. Find the lowest possible score to qualify for the academy. In this case, first we need to identify what the random variable we're interested in is. So x, our random variable. So capital X is our random variable, and this is the test scores. And what is the distribution of these test scores? They are normally distributed with a mean of 20, or mean of 200, and a standard deviation of 20. Now, the first step is to draw the normal curve and shade the appropriate region. That would look like this. So here I have my distribution. So in the middle, I have 200. And it says I need to score in the top 10% in order to qualify for the academy. So the top 10% means I need to score right here such that the area to the right of me is equal to 10% or 0.10. So that value here is x, the unknown value we're looking at. Now, we need to find the corresponding z-score to this area to the right. Now, if this 0.1 is the area to the right, then the area to the left is just 1 minus that, so the area to the left here is 0.90. So let's look at this second step. Find the z-score in the table. So this step said find the area to the left of the unknown x value, then use the table to find the corresponding z-score. So I know the probability to the left of this, so then I can find the corresponding z-score to that, where I have the probability of getting a z-score less than or equal to this unknown z-score, little z, let's call it z naught, is equal to 0.90. Then, if I look in my standard normal table, I look for something with this area to the left. So 0.90, the closest I can get without going over 0.90 is 0.8997, and that is at 1.28. So this implies that z naught is equal to 1.28. Let's make this a better 8. 1.28. Now we know the z-score corresponding to it. Now all we need to do is convert it to a x value using this formula up here. So convert to x value. And to do that, we just use x equals z sigma plus mu. And z in this case was 1.28. So we have 1.28 times sigma, which was 20, and then plus the mean of 200. And if we do that math, we get 225.6. And that is the minimum score you need to qualify for the academy. So again, let's kind of go through the logic here. So in order to qualify for the academy, you need to score in the top 10%. So that means you need to have some score such that 10% of 10% of the people are above that score. So that means the area to the right of this score should be 0.1, and the area to the left is just 1 minus that. Then I know the area to the left is equal to 0.90, so I can find a corresponding z-score with that area to the left, and I did such. And then I can use this formula up here to convert this z-score into the data value because I know sigma and mu, and I just found the corresponding z-score above. So that is how you do that. Now let's look at another example real quick. It says, for a medical study, a researcher found that blood pressure readings are normally distributed with the mean of 120. If the probability of having blood pressure above 140 is 0.0125, find the standard deviation. So this one is a little bit different, so I will go through it. In this case, the random variable we're looking at, x, is just blood pressure. And what is the distribution of x? So the blood pressures are distributed normally, and it says with the mean of 120. But it says we need to find the standard deviation, so we don't know sigma yet. So sigma is unknown. Now, let's look at what we're given. So first, let's draw the normal curve. Here, we have the distribution of the blood pressures. Here is the mean of 120. And here we have 140. Now, it's telling us that the area to the right of 140, so this area over here, is 0.0125, because it says if the probability of having blood pressure above 140 is 0.0125, that means the area to the right of this blood pressure reading is 0.0125. Now I can find the area to the left of that by just taking 1 minus the area to the right. And if I do that, I should get 0.9875. Now, the second step. Find the corresponding z-score with area to the left of this. So find corresponding z-score such that the probability of z being less than this unknown z-score z0 is equal to the area to the left of this, which is 0.9875. Now let's look in the table for the closest one. So 0.9875 is actually right here, 2.24. So this implies that our z0, the unknown z-score, is 2.24. Now, the third part is to calculate sigma. Now, we know from earlier that x is equal to z sigma plus mu. But we want to solve for sigma here. If we do that, we have x minus mu over z equals sigma. How did I get that? So the first step, subtract the mu over, and you have x minus mu equals z sigma. And I want to solve for sigma, so just divide both sides by z. Then the data value we're interested in was 140. The mean was 120. And the corresponding z-score we got was 2.24. So that means that this is equal to sigma. And what is this quantity equal to 2 decimal places? It is 8. That is an ugly 8. 8.93. And that is how we solve for sigma. So that is how you would do it. So you should be able to know how to find the mean as well. So if I tell you it's above or below something, I tell you the probability, you should be able to find the mean as well if I tell you the standard deviation. So there is actually a couple sections in this chapter that we will not go through just because we had a snow day and we're also missing another snow day. So on page 17, it says checking for normality. We are not going to do page 17. Also, we're not going to do page 18. We're not going to do any of that. And finally, we will not do any of page 19, but we will start right here at section 6.3, and we will talk about the central limit theorem, and we will talk about that next time.